The sides AB, BC and CA of the triangle ABC are defined by the equation 5x minus 3y plus 2 equals to 0, x minus 3y minus 2 equals to 0, and x plus y minus x equals to 0 respectively. We need to determine the equation of the altitude from vertex A to the opposite side. Okay, let us begin. First, let's try to quickly understand the problem graphically. So here we have the triangle ABC. The side AB is represented by the equation 5x minus 3y plus 2 equals to 0. Then we have the side BC. BC is represented by x minus 3y minus 2 equals to 0. And then we have the third side CA. CA is represented by x plus y minus 6 equals to 0. Now, our goal will be to determine the equation of the altitude drawn from the vertex A to the opposite side. That means we need to find out the equation of AD. Now, in order to find out the equation of AD, we need two things. We need to find out the coordinates of the point A as well as the slope of the line AD. Finding out the slope of line AD, that's easy because AD being parallel to BC, we know that the product of the slope of two perpendicular lines always equals to -1. Which means using the slope of BC, we can find out the slope of AD. So let's do that. So let's start with the equation of BC. So here BC, we have x minus 3y minus 2 equals to 0. So rearranging the terms, we get 3y equals to x minus 2. Let's divide throughout with 3. So we get y equals to 1/3 of x minus 2/3. Now clearly, what is the slope of this line here? So here, when we compare it to the slope-intercept form of a line, y equals to mx plus c. So slope of the line BC, that is going to be equals to 1/3. So we have now obtained the slope of BC, and we know that since the line AD is altitude on BC, we can say that AD is perpendicular to BC. This must imply that slope of the line AD times slope of the line BC, that is going to be equals to -1. Since we have the slope of BC, so we can find out the slope of AD, that comes out to be equals to -1 over 1/3, or in other words, we get -3. That's going to be the slope of the line AD. Okay, now we have the slope of the line AD. We got it as -3. Next task will be to obtain the coordinates of point A. Finding out the coordinates of point A, that's an easy task. All we have to do is take the sides that are adjacent to A. So those sides are AB and AC. So if we take the sides AB and AC, we already have their equation. We're going to solve those two equations, and the values of x and y is going to give us the coordinates of point A. So let's do that. So we're going to take the equation of AB. So that's going to be 5x minus 3y added to 2 equals to 0. Then we need the side AC. So AC, that's x plus y minus 6 equals to 0. But what we'll do, we'll take the side AC and we're going to multiply each terms with 3, such that we get 3x plus 3y minus 18 equals to 0. Let's add up the two equations. So 5x added to 3x, that gives us 8x. Negative 3y and positive 3y cancels out. Then we have 2 minus 18, so that gives us 16. That's going to be equals to 0. So solving for x, we get x equals to 2. So now that we have the value of x, we can substitute x in either the equation of AB or that of CA to find out y. So this gives us the corresponding y value as 4. So that means the coordinates of the point A, that's going to be 2, 4. So now we have the altitude AD passing through the point 2, 4, and it has a slope of -3. So here we can use the point slope form of a line to obtain the equation of AD. So we need y minus y1. So let's say x1, y1 corresponds to the coordinates of point A. So y1 is going to be 4. That's going to be equals to the slope, which is -3, multiplied to x minus x1. So x1 is going to be the x coordinate of point A. So let's simplify this. We now have y minus 4 equals to -3x plus 6. We get 3x plus y equals to 10, and this is going to be the required equation. So we can say thus 3x plus y equals to 10 is the required equation of the altitude AD.